Hello and welcome to Chapter 4, Section 5. Today we're going to talk about the equations of parallel and perpendicular lines. So the slope of a line is the relationship of rise over run. So rise is the change in y and run is the change in x. So this is how much it gets higher or lower, and this is how much it goes left or right. And the change is actually when you pull 2 points off of the line, it's both of the y's subtracted and both of the x's subtracted, making sure that you do them both in the same order. So in order to review, we're going to graph these two equations. We're going to graph y equals 2 times x plus 1 and y equals 2x minus 3. So first we're going to distribute this 2, and then we're going to come up with, we'd make a basic function table that we'd use to graph these two y's with our x's right around 0, both going negative and positive, and figuring out what our x's are. So when we graph these points, we have negative 1, 0, 0, 2, 1, 4, and 2, 6. And when I draw a straight line for this graph, it looks like that. The second one is negative 1, negative 5, 1, 2, 3, 4, 5, 0, negative 3, 1, negative 1, and 2, 1. And when I draw a straight line for this graph, it looks like that. And if I could draw actual straight lines, there we go, you could see that these lines are parallel. They're parallel because they both have the same slope. And slope is rise over run. 2, 1. 2, 1, 2, 1. 2, 1, 2, 1. Parallel lines have the same slope, but they pass through different points. So if you look at Explore on the very first page of 4-5, where they graphed the equations for these two lines, we know that the lines are parallel and the slopes are equal. And when we look at C, we see that with a perpendicular line, the lines cross at a 90-degree angle. And that's the definition of perpendicular. And for these particular lines, and let's start a line here, they're going to go down 1 and over 3, down 1 and over 3, down 1 and over 3. And that's their line. You could also go up 1 and backwards 3, up 1 and backwards 3, up 1 and backwards 3. So that negative line either means you're going left, which means you're not going in the direction that you read, or you're going down. But it can't be both, because both would give you the backwards line. Now to find the line that's perpendicular to this, we need a slope that's an opposite reciprocal, which means negative 1/3 gets flipped and the negative becomes a positive. So our new slope is 3 over 1. So we're going to take any of these points and we're going to go up 3 and over 1, or we could also go down 3 and backwards 1, down 3 and backwards 1, down 3 and backwards 1. And this line is now our perpendicular slope because they have an opposite reciprocal slope. When you're writing the equation of parallel lines in slope-intercept form, remember that slope-intercept form is y equals mx plus b. Y and x are any point on the line. Any point that you choose you can stick in for y and x, and this would be an equal equation. The m is the slope, and the slope is the ratio of rise over run. And then b is where it crosses the y-axis. So there's your little quick review of slope-intercept form. So if we were going to write the equation of the line that's parallel to y equals 5x plus 1 through the point negative 1, 2, we're going to want to know how to plug all that information into this. Now, because it's parallel to it, we know what the slope is going to be. So we're going to take the same slope. Parallel lines have the same slope. However, this line, instead of going here, it's either going to go here or it's going to go here. It's going to have that same slope, but it's going to pass through the y-axis at a different place. And we have to figure out where it goes through. We have to solve for b. We have x and y. Here's our new point. So here's our new x and y, and we can go through and solve for b. We can put in the m, the x, and the y and solve for b. Or, another way to do it, we could use the point slope form, which is y minus y1 equals m times x minus x1. So it doesn't have a b in here at all. We can put in x1, y1, and m, and it will give it to us. If we use the point slope form for this, we have y minus y1 equals m x minus x1. So y minus 2 equals 5x, x plus 5. And we're going to add 2 to both sides. And we're going to get y equals 5x plus 7. Here, if we take 2 equals 5 times negative 1 plus b, and we solve for b, 2 equals negative 5 plus b, and we add 7 to both sides, b equals 7. So now we have y equals 5x plus 7. So we can solve it either way, whichever one you're more comfortable with. I'm going to ask you to pause here and try b. And come back when you're done. For b, we want to find the line that's parallel to y minus 3x plus 4 that passes through the point 9 and negative 6. So you could do it with the slope-intercept form and stuck 9 and negative 6 in here to solve for b, and you ended up with b equals 21, so this was your line. Or you used the point slope form and you ended up with this as your line, and they're the same line, and so you could do it either way you want. So pause here, try your turn numbers 4 and 5, and come back when you're done. Our line is y equals negative x, and it passes through 5 and 2.5, and so we end up with the line y equals negative x plus 7.5. And for 5, we want to go through the point negative 4, 0, so our line ends up being y equals 3/2 x plus 6. Next, we're going to talk about writing equations for perpendicular lines. So a line that is perpendicular to y equals 4x minus 2 that passes through the point 3, negative 1 is going to be what we look at first. So we're going to rewrite our slope-intercept form to include our new x and y and our new slope. Now this slope, for a perpendicular line, we need to have an opposite reciprocal. So this was positive, so now it's negative. This was 4, and now it's 1 over 4. And it's negative 1/4 times our x plus b. So when we do the multiplication and we add 3/4 to both sides, we end up with 1/4 as b, so y equals negative 1/4 x plus 1/4 is our answer to this one. A line perpendicular to y equals negative 2/5 x plus 12 that passes through this point, we're going to take negative 2/5 and do the opposite reciprocal, which is positive 5/2. And we can do this one, the point slope form. We can take our x1 and our y1 and our new slope and do the math here and Subtract 8 from both sides, and we end up with y equals 5/2 x plus 7. So you can do it either the slope-intercept form or the point-slope form. So here I'd like you to pause and try reflect number 6 and your turn number 7, 8. Come back when you're done. For number 6, the answer is because both lines are perpendicular to the same line. So then we have number 7 and number 8, and both of them I had answered with point-slope form, it looks like. So y equals 3/2 x plus 2 going through this point gives us y equals -2/3 x plus 1. And y equals -4x going through the origin gives us y equals 1/4 x. So if you could pause here and do elaborate numbers 9, 10, and 11, we're almost done with this section. Number 9, no. Parallel to a line and sharing a point means they are the same line. You can't have a line that's parallel to something and sharing a line, because by definition parallel lines never cross. Therefore, if it shares a point, that means it's actually the same line. Number 10, yes, because they will share one point and exactly one point. Number 11, parallel lines have equal slopes. Perpendicular lines have opposite reciprocal slopes. Our homework for tonight is numbers 1 through 22 all. I hope this works for you, and I will see you next time. Take care.